I am back. Yesterday we put together a website, a little static web page for an app that I have called Smart Medical Apps. It looks like this. It's great. Static site went real well. But I noticed this little lockety thing up here. It's circled slash through it, or I guess lock with a slash through it, and I am not pleased about that. HTTPS SSL encryption for websites is real common here in 2021, and we should be on board with that. So today I'm going to add a Let's Encrypt. It's a free cert, a free certificate. It'll last for about 3 months, and then I can go back and redo this however many times I need to. But I want to go through the process of adding a new website to that. I'm going to use a tool called certbot, which has a bunch of automation around it that can make that really easy. But I'm not going to use that automation. I'm going to do it the hard way. I'm going to go through and actually verify my domain using certbot, using a challenge response thing, show you what that looks like, and then show you what comes out on the other side, and then how I install it. As it stands right now, if I try to do a little HTTPS on this, it'll give me an error because I'm using a generic cert. I'm using a certificate for a different website. My web server doesn't know what cert to use for this, and so it just picks whatever its first default is and goes there. That's not great. And in fact, if I do some curl, I can see the same problem. Smart Medical Apps. This is, oh, yeah, no, this is bad. No alternative certificate name matches target host. It does give me a normal host for my personal website, leatherheads.net, and then it says curl will not negotiate with this because it does not work right. I'm like, okay, cool. So what do? First off, let's get a copy of Cert Manager, or certbot. And certbot, there's a handful of ways you can install it. You can install, download some binaries. You can do whatever you want. But at the moment, the way that I prefer to do it is to use a Docker container, or because I'm on a newer version of Fedora, a Podman executed container. They've standardized the container structure, so we can say it's Docker container in the same way we can say it's a Xerox. It's a standard way to run containerized applications, and we're going to do that. So went and got a copy of certbot. If you were watching yesterday, I had timed myself out, unfortunately, from Docker Hub. I had pulled too many Docker images over the course of the last 6 hours, and Docker made me go sit in the corner for a while. So we're back today. I actually got a copy of the app and made sure that happened before I turned on this year's stream. So I've got a copy of that, and I can Podman run it. I've written some scripts before just to remind myself what it is that I'm doing. And in this case, we started to put this together yesterday, and I want to run, I want to do Podman run, which is fine. I want to clean up after myself, and I want it to be interactive. These volumes become important, and we'll talk about that here in a second. I want to run the certbot thing. I want to only just spit out a certificate. I don't want it to try to install anything because I'm running this on my laptop, and I'm going to eventually push it up to the server over the course of this kind of investigation. We're going to do it manually. Here are the domains that I'm covering, Smart Medical Apps and www.smartmedicalapps.com, and this is just what I want to run. So a thing that I can do to make this a little bit easier on myself is add a shebang line, and that just tells the operating system what kind of script this is. So I can say /SMA, and it'll figure it out. Following error was encountered, permission denied. Let's encrypt certbot lock. So run as root or second config error worked. So a problem that I believe we were going to run into was that I'm used to running this in Docker. And Docker and Podman have slightly different visions for what users look like and for what user identities look like. There's a whole UID mapping thing inside of Podman that exists inside of Docker, but nobody uses it. So that becomes important whenever it's trying to read and write files in volumes. Because the identity of who you are as a user is what determines your ability to read and write files in a volume or files on a file system in general. And so we're going to run into some complexity with that. Well, let's see what we can do. So I've got this Etsy output situation going on here. And if I look in there, everything is owned by the Billy user. And that should be what attaches itself to Etsy Let's Encrypt. So what I want to do is say, let's do some investigating. If I say this But I say the entry point is bash. I just want a shell in here. And I want to run it as this. Doesn't have bash. How about regular sh? Hey, lovely. Who am I? So I'm running as the root user inside the container. Great. Okay, cool. And then outside container, who even knows? One of the reasons Podman gets kind of interesting with this is because Podman doesn't have a root context on the host box, so like there's no socket it's talking to like in Dockerland that has elevator privileges on the host. It's running entirely in low privilege mode, which gets complicated, and that's where we are right now. So if I say, if I want to do all of this, look at that as that, and then, yep, it's the output, and I want to run entry point bin sh, I want to do the same thing. I'm like, okay, cool. So that mounts this volume, and I've got a shell, so I can poke around, and let's see what we can do. I'm still root. Great. Love it. So if I say, let's see, let's encrypt, can't open dot. Excellent. Great news. So this entire volume is not available for my use. Cool. Good information. If I go over here to temp, there's nothing in here, touch blah, I can do that. So inside the container, I'm relatively powerful. And the question is, how do I get outside of the container? And the answer to that is something inside of Podman. Let's figure it out. Okay, yeah, sure. So Podman, right, is your volume, right. Volumes, yes, there's a lot of these. Permission denied bounding volumes, like, oh, this good stuff. Volume for container with custom user is not writable. Really what I'm going to have to do, using volumes with rootless Podman, which is where I'm at. Cooperates willingly with SE Linux, great. Rootful, this is, yeah, so great. Non-root is my UID, great. And user namespaces. So one of the fun things that this could be running into, and I have not actually checked, is SE Linux. SE Linux is an additional layer on top of the normal file system, like who owns files or whatever, to make sure that like weird stuff can't happen with your container. Decent chance I'm running into that problem. Let's see, we've got some nice videos. Rootless containers are in a namespace. That's all very exciting. Share and unshare. What is check listing? Yeah, there we go. Oh, I got to add a -z. Add a -z. Doesn't allow the volume to be shared with other containers. Love it. So if I add a -z, what does that do? Does that help? :z, or dat, not :z, dat, or yeah, one of those. So now if I say let's encrypt, hey, we got some stuff in here. So that -z talks to SE Linux. It doesn't actually change any of the identities of files or anything, but SE Linux is, like I said, an additional layer on top that this thing's going to negotiate with. So let's see, let's touch blah. Right? Hey, we got a blah. Excellent. So one of the fun questions to ask is, all right, so we made a blah. Who owns that blah outside? And the answer is Billy. Nice. Okay, cool. So it's doing the user mapping correctly. Runs as root inside the container, gets mapped to Billy outside the container. Love it. Love this. I can remove it. Okay, fantastic. So that part works. So now, if I update my script to include z for the output har, and the little :z for the output har. Now I run it and should be able to lock things a little bit more excitingly. Okay, so enter email address. I have a cert. What is my let's encrypt email address? I think it's just let's encrypt at. Let's encrypt at. I've got one of those. I have read the terms of service. I swear to you, I have. Share my email with EFF. Yeah, that's fine. Requesting a certificate for these two. Okay, so now we're in the fun part. What we want is to be able to get to this and have it make this content, which is relatively simple, relatively straightforward, because we've got like a static website that we built yesterday. So if I say .net, And I go to var www smart medical apps. Cool. And I make a well known. I'll spell it right the first time. There you go. CD well known. And then make an Acme challenge. Acme challenge. Fantastic. This is what certbot does normally, like automatically. Like this is the thing that like certbot will deal with, like putting this in the right place in the file system, and then like issuing the challenge, and then getting the cert, and then installing it. But this is the manual part that we're doing. So I want to have just this data. So I can say echo that, and I want to do -in for don't add an additional new line. I don't super think it matters, but here we are. And I want it to be in this file here. So put it in that file. And I did that. So if I cat that one wacky file, cool. And a thing that I can do to verify this before things go nutty is I can curl that, and it should come back with exactly this data. Cool. Enter to continue. Love it. Then it gives me a second one. It's like, oh, hey, well, you did it once. Why not do it again? So yeah, we can do this thing again. And it's the exact same process. Echo it. Echo writes whatever it's handed, whatever string this is, writes it to standard out. And then this greater than sign redirects standard out and says, anything that comes out of standard out of this program, put it in the following file. Bash has a lot of really delightful redirects, and everything's file handle, and it's super interesting. We can totally talk about that at some point in the future. So we can do that again, and we want to make sure that that is available here. Where did that go? Yeah, there you go. And we can verify that it works. Hey, it worked. Cool. Enter to continue. Waiting for verification. Cleaning up the challenges. Subscribe. Love it. Got the EFF mailing list. Congrats! Your certificate and live chain have been saved at, and this is why it was important for us to mount those volumes, is because it writes, certbot writes out your certificates that it goes and gets, and your private keys and all of that stuff. It writes it out inside the container and then shuts itself down. The first handful of times that I ran this totally screwed that up, and as soon as it finished, the container was destroyed and it's gone forever. And I'm like, oh, great. So then I had to redo it, and it was super annoying. Your key file has been saved here. It's a super secret key. Great. Full chain here. So important things to note. This full chain is totally public. Like, you're going to put that on your website. Like, it is going to be 100% super public. This, your private key, very private. Don't share that. So for instance, I'm not going to open this up on screen. I am, however, going to look at this. Let's look at what this file is. If we remember, we mapped this etc let's encrypt to etc output. And if I look at live smart medical apps full chain, these are certificates. This is what a certificate looks like. It is a bunch of letters that describe a series of numbers in computery language. I can see what does this thing actually look like. And I do that with a command called OpenSSL. This is on a lot of different platforms. Mac has it, Linux clearly, you can get it for Windows. It's all free software. If I say this is an X509 certificate, X509 is a super old, I say super old, it's a standard from the late 20th century about what certificates need to look like, about what these MII letters mean. And I say I want to read in this file. I don't want to write out any other file, but I do want to dump it to text, and it'll tell me what's in there. In particular, it'll tell me the first site, or the first certificate. You'll notice this is a full chain. So this is the certificate that talks about smart medical apps. And it does quite well. It says, all right, this attaches smart medical apps to a number and signs it from Let's Encrypt. This second certificate, and we can look at it later if we really need to, attaches Let's Encrypt to a root, to a trusted source of some kind, and says that the thing that signed this certificate is also signed by a trusted, a source of trust. Your web browser has a couple hundred sources of trust in it, built in, like whenever you download it from Google, whenever you download it from Mozilla, or if you use one of those others, whatever. that have a series of trust points in them, like places that they trust, this cryptographically connects the certificate you just got to one of those sources of trust. So we've got it. We've got a full chain and a private key, which is great. Those are the two things it turns out that we need in order to make our website work. So what I'm going to do is I'm going to I'm going to SCP that file up to my web server. I'm going to put it in home, Billy SMA fullchain.pem. I'm just going to copy it up. There it goes. And I'm going to do the same thing with the key. Where's that key at? It said private key. This one right here. So this proof key. Cool. We'll copy that up too. All right. So the actual negotiation with Let's Encrypt is entirely done. They verified it. They sent us this certificate, and then the private side, the key. The public side is the one that people can verify. The private side is what allows whoever holds this private key can say they are smartmedicalapps.com. So let's go and take a look at it. Cool. So I run, the web server that I run on this is called Nginx, a delightful little division of, I think, the F5 Corporation at this point. It is running a relatively old piece of, a relatively old operating system. It's an operating system from probably 7 or 8 years. It's Red Hat 5. Which is real old, but Nginx comes with its own like binaries that have modern cryptography and things like that, and runs just fine. And eventually I will upgrade that and probably do it on stream. But that's where we're at today. So if I wanted to look at Nginx and say, what does my configuration look like for these other websites? I can say, oh, look, here's old WilliamLourance.com. We got this. And all right, we got a bunch of this stuff. Looks good. A bunch of these things. Love it. Here's all of my SSL configuration. This tells me where the logs are. Gives me the certificates. Great, love it. Excellent stuff. Default, if you remember default, this should be BillyRance.net, and this has the Let's Encrypt cert that provided this warning. This tells Nginx what the default certificate is, and is why that came up with a BillyRance.net. Cool. So let's do that. Okay, so what we're going to do is we're going to copy WilliamLourance.com over here to smartmedicalapps.com. Yep. I need to be root for this. Okay. Copy WilliamLourance to smartmedicalapps.conf. And let's edit this. So basically, I want everywhere that it says William Lourance to actually say Smart Medical Apps. And yep, that looks good. That one, totally. Yep, server name needs to change. Here's where we need to put our, here, I'm gesturing with my finger. These two are where we're going to need to put our certificate and our key. So that'll be important here in a moment. Access log looks good. Error log, yep, there we are. So that looks right to me. And then it passes through to the thing that's actually running the website, which is Apache, which is the slightly different web server that I've used for years and years. The reason I have two, Nginx does way better at like load balancing and the crypto stuff. Apache has plugins for old software that I continue to run hilariously, Perl CGIs and PHP and things like that, that one of these days I'll probably get rid of, but not today. Cool, so we can write that, and we need, the important bit here is we need these two keys, or we need these two files to exist. So let's take us a look-see. All right, so we want this one. Let's do the full certificate first. Where do we put that? Put that in SMA full chain to that. Okay, easy enough. And then we want to copy up the file we did the private key. I'm going to send that to this file over har. Cool. And that should be most of what we need. We can take a look in here and make sure that this has like, vaguely the right. Okay, it's owned by root. Looks pretty right. Permissions look pretty okay. And then we can make sure that this looks relatively okay also. Yep, we got some keys. Yeah, this is fine. It's not going to collapse this key there. Love it. Excellent. So if we say, if we restart our web server, and actually we can do, with this version of Linux, there's actually a config test that you can do that will verify that. And it says the configuration file is okay. Configuration file, syntax, everything looks right. So we should be able to do restart. And that will restart the web server, which should pick up our key. Once that happens, it is now it now knows to associate the smartmetacollapse.com name with that key. And ideally, if I go to this now, awesome. Oh, it looks ugly. Connection's not secure. Oh, that's why. If you recall, whenever we built this thing yesterday, we said not to use. We said not to use HTTPS. So let's change that. Let's make it use HTTPS now. So let's go back to Smart checkouts. We're gonna put the SMA homepage. So this is what we were fiddling with yesterday. And so if I say http:// we should edit some of these files. We should edit that, and then update these to be HTTPS. Cool. Here's our base URL. Let's edit that. Yeah, http:// Let's edit. And, be sure to talk to your lawyer before modifying licensing and other such stuff. There are ways to move the cursor faster, which I am not currently doing. That's all of that, and cool, and that's all the files. Excellent. So git status, git diff, we added that, added some stuff to the make file, so if you say git add blah, git add HTTPS for the site. You put forge in main, and then yeah, there should be a make publish that builds this and sends it up just like yesterday. And it's still hideous. Why is it still hideous? There it is. Shift refresh, and it works. Got this nice little lock. Connection's secure. We can look. It's verified by Let's Encrypt. We can view the certificate, and this should look. There's your Smart Meta Collapse. There's your Let's Encrypt R3. Not before, not after. So I got to remember to update this sometime in May. Which putting that on my calendar is a thing that I'm going to do very shortly. But that should look really similar to whichever one. Where did I put that X509 business? It's one of these. Is it this one? No. Wherever it was. It's not that one. I want to show this off. Okay, here it is. So this is the X509 dump that we did for that certificate. And it says things like, here's the issuer. It's Let's Encrypt, it's R3, here's your not before, not after. This certificate is literally the thing that is being sent to my browser to show me this stuff. Like, it's literally this. When I say that the public side of a certificate is very public, like, I mean that. There's nothing magical about it. It is the part that is sent in plain text, in the clear, to a browser in order to say, let's set up a secure negotiated website. No magic there. The magic is all in the math between the key and the actual certificate itself. So yep, there's your fingerprints, blah blah blah. All this stuff looks good. Other stuff we can do. So Smart Meta Collapse looking good. We can verify that it works in curl. Let's go ahead and get rid of this. We can verify that it works in curl. There's your HTTPS, and oh yeah, there you go. See, now this is actually working. Here's your actual content of your web page, and if we scroll all the way back up, this should have some of the same information. Here's that same certificate that's being shown to curl. Has the same start date, same expire date, has an alt name that works right, subject looks right. We should probably check and make sure the www works. Www works good. Excellent. Love it. And that is the primary stuff that we want to do. So making sure that we are all aware, we ran Podman. Podman ran Podman to do certbot. We use certbot to say, make a cert only, do it manually. Here are the names of my domains. Gave it some places to put its output. Followed the instructions in certbot, put some files at particular locations to verify that we own the actual unsecure side of smartmedicalapps.com. And then it said, all right, I believe that you own the insecure side of Smart Medical Apps. Here's a way you can secure that. And gave us certificates. Certificates and then a private key. We uploaded the certificates and the private key to our server, attached them in the right places, restarted the web server. Everything's golden now. Awesome. Thank you all for playing. Relatively short stream today, 30 minutes. It's a Sunday. It's cold. Actually, it's not cold. It's 36 degrees in Chicago, and I walked outside in a t-shirt and flip-flops and was like, this is balmy. Just feels wonderful. But yeah, have a wonderful weekend, everybody. Love you all tremendously, and I will see you on the next one. Bye.